everyone, welcome to Scribble. In today's lecture, we are diving into basics of electric circuits, the core stuff you need to know before starting your circuit journey in ECE. Whether you're a complete beginner or just brushing up before exams, this is one for you. So let's get started. First, we'll start from the really basic stuff. So first, what is network? A network is a connection of two or more circuit elements. So that is called as a network. So what is circuit then? A circuit is a network with at least one closed path. If it has at least one closed path, then that is circuit. Now, what is a matter? Okay, before entering into charge, we'll talk about matter. Matter is nothing but anything which has mass and occupies some space in this universe, then that is called as a matter. For example, you can take an example of a phone. A phone, it has a mass and it occupies some space in this universe, so that is a matter. And generally, a matter is made up of atoms, and atoms are made up of electrons, protons, and neutrons. Electrons are negatively charged, protons are positively charged, and neutrons are neutrally charged, which is no charge generally. Now, unit of charge is coulomb, which is very important, and charge of an electron is 1.6 into 10 power minus 19 coulomb, so which is very important thing. You should never forget this value in your lifetime. And like charges repel each other, unlike charges attract each other, so we all know this obviously. And voltage is nothing but it's a potential drop between these two things. Okay, potential difference. So if you have 2 points right here, and if there is some potential difference between these 2 points, that causes voltage. That is voltage. So the potential difference between these 2 points is called as voltage, and the unit of voltage is volts. And voltage symbol is generally we'll draw the voltage symbol like this. This is positive and this is negative. So generally we'll draw the symbol as this, like this. And what is current? Current is a rate of flow of charge is called as current. And if you take an example of some semiconductor device, you will have a flow of electrons in this, right? So if you have some flow of electrons right here, then that is current. So rate of flow of charge, and it's nothing but charge per unit time. So dq by dt. Q is nothing but charge. And if the charge travels fast, the current is high. If it travels low, then the current is low. Unit of current is ampere. And the current generally the current flows from higher potential to lower potential. Conventionally, so they are using the word called conventionally. So it is conventional. So yeah. Now, what is power? Power is a rate of change of energy. So rate of change of energy is called as a power. And it's W by T. Unit of power is what? And P is equal to V into I. So V is voltage into current. So current into voltage will give you power. And there are so many other forms of power also. We'll talk about it later. And energy. Energy is nothing but if it has a capacity of doing some work, anything which has a capacity of doing some work, then that is called as an energy. I'm going a slide fast because this is very simple. And W is equal to P into T, and unit of energy is joule. Yeah, you know. And yeah, okay. So how can I say a circuit is an electric circuit? To say a circuit is an electric circuit, you have to have essentially these three parts. One is a battery or some energy source, not only battery, some energy source, some load, and a wire. So if these three are there in a circuit, then I can say a circuit as an electric circuit. An example is given. So this is an example. You have a load, some load. You can also have a resistor or capacitor or inductor or whatever, and you have a switch right there, and you have a wires, and this something which has like everything, like these three generally, then that is called as a electric circuit. Now a very important law is Ohm's law. Ohm's law, it states that current in an electric circuit is directly proportional to the voltage applied at a constant temperature. So it's generally V is directly proportional to I. And actually to convert the directly proportionality symbol to equal to, you have to add a proportionality constant. Here I'm adding a proportionality constant R, which is resistance. So it's V is equal to IR. So this is what Ohm's law means. Okay, V is equal to IR. So it's a very important thing. And the graph also comes like this. This is voltage and current. And yeah. And with this Ohm's law, I can term power. So we said that V is equal to I into R. This is Ohm's law. And we know that power is equal to V into I. So V is equal to IR. I can just substitute it right here. So P is equal to I square. Oh, what? Okay, I square R, or from this I can write I is equal to V by R. So P is equal to V square by R. So these are the different forms of power. So P is equal to VI, P is equal to I square R, or P is equal to V square by R. So these are the different forms of power. Now coming on to the resistance. If the circuit has a resistance, high number of resistance, if the circuit has more number of resistance, then the current flowing through the circuit will be less. So that is so obvious. And if it has less number of resistance, the current flowing through the circuit will be more. And the unit of resistance is ohms. Yeah. The resistor is a component which is made up of carbon. So generally a resistance is a component made up of carbon, and R is equal to V by I. So V is equal to IR, R is equal to V by I. So yeah. And unit, a symbol of resistance is this. But generally you have to draw from starting above, and you have to like stop from down. Stop from here. Like you have to start here and stop here generally. So this is like, it's a wrong thing. So and yeah, when the current flows through a resistor, there will be a voltage drop across a resistor. And this, if there is a voltage drop across a resistor, then that results in a power consumption. All right. Now, generally, current flows through a closed circuit, not an open. If the circuit is open here, let's assume. And how can a current flow? The current will stop here itself, right? So the current can flow only through a closed circuit, not through an open circuit. Now we'll see a sum based on the thing. So here voltage is given and current is given, and they are asking you to find the resistance. So B is equal to IR, R is equal to B by I. So it is 100 by 2, which is 50 ohms. Alright. So yeah. Now draw a circuit with 4 ohm resistor connected to a battery if the circuit current is 5 ampere. So resistance is given, current is also given. So V is equal to IR, 4 into 5, 20. Alright? Yeah, this is very simple. Now, find the current through the circuit when a 6 ohm resistor here, resistance is given. Resistance is given as 6 ohms and voltage is given as 30 volt. So V is equal to IR, I is equal to V by R, 30 by 6, 5. Alright. Now, coming on to the next important topic, how to find whether a circuit is series connection or a parallel connection. So, generally, if this is a resistor, okay, it has two ends right here. If only one end is connected to other resistor and the other end is left free, if only one end is connected to other resistor and other end is left free here, then this connection is called as a series connection. If both the ends are connected to like this, if it is connected, then that is a parallel connection. So series connection, and the formula for series connection is, so for this circuit it's R1 plus R2 plus R3. Oh shit. Okay. So it's R1 plus R2 plus R3. So that is R equivalent. So for example, this, so it is nothing but 20 plus 40 plus 60, which is 120. And for this also 1.8 plus 2.2 plus 6, which is 10 kilo ohms. Okay, this is kilo, so obviously. And this is also series because you can see here only one end is connected to other resistor, not the both ends. So this is obviously a series circuit. So you have to just add the three things. So this is also series because this end is connected to this end is connected to this resistor, this is connected to this, and this is, so yeah. So this is a series. Now coming on to a parallel circuit. So I said, right, so if both the ends are connected to each other, then that is a parallel circuit. And parallel circuit formula is R equivalent is nothing but, you can name it as, okay, 1 by R equivalent is equal to 1 by R1 plus 1 by R2, or you can also write it as R1 R2 by R1 plus R2. Alright. So yeah, R1 R2 by R1 plus R2. So this is the thing. So how will you do this? 80 into 20 by 80 plus 20. Alright. And I will tell you a trick. If three resistor, okay, we'll solve this also. If this is nothing but 40 into 60 by 40 plus 60, because it's parallel obviously, because both the ends are connected to each other. And here also you can see this is connected to this, and you can also say a thing is parallel when, like, if you have a resistor like this, then these two resistors are parallel to each other, because here one more connections are there. If here there is nothing, if it is like this, then this is series, whereas if it is connected like this, then it is parallel. So same way goes on here. So yeah, I hope you get it. If you don't get anything, you can just comment below. Here, 50 into 50 by 50 plus 50, obviously. And there is a trick, that is R equivalent of two equal resistance. If two equal resistance, like two equal resistance means 50 kilo ohm and 50 kilo ohm, they are equal. Then you can use a formula 1 by 2 into 50. If there are three resistance in parallel like this, then you can also, with same value, then you can use 1 by 3 into this value, the resistance value. So that is also a trick. So if there are three resistance value, you can also use it. And if the circuit is given like this, okay, if the circuit is given like this, then first you have to take any two things which is parallel. So first, if you take 20 and 30 as parallel, first you have to do this. Then with that answer, you have to make it parallel with this 12K. So that is how you will generally do it. Okay, so now these three resistance, so you can do, okay, I said, right, so 18, 18, 18, 3 are equal resistance, so 1 by 3 into 18, which is 6. So you can do like this also. For this, 1 by 3, 1 by 4 into 20, which is 5. Yeah, so it's, so see, R equivalent of N equal resistance. So this is applicable only when the resistances are equal. Then you can apply this thing. See this, how will you solve this? This is also parallel, so 1 by 6 plus 1 by 4 plus, or else you can take any two resistance. So 6 and 12 first parallel, then in parallel with 4K. So that's it. So that's it, guys. So thank you so much. I hope every concept which is there in this video is clear. And if you have any doubt, you can just comment in the comment section below. So thank you all.